Teen Geek Online School. Yes, indeed. This is our very own digital school. If you have just joined in, you are in the grade 11 physical sciences class. And yeah, I hope you guys had a great rest and great holiday throughout this time and had a lot of time to go back to your work and study some more physics, study the next chapters, and everything that's happening is just happening so fast. But I'm glad that you guys are here joining us on Africa Teen Gigs STEM Digital School in order for you guys to enhance your education, because at some point indeed you will be going back to write your exams, and you might even write them online, who knows. But the biggest part is about you guys getting prepared for it. Today is the 1st of July 2020. We are back from our recess and we are starting off with term 3 work. So I hope that everybody is prepared for that, and everybody was well prepared in all the work that we did before we closed for the recess. Just going back, I remember just before we closed schools, we were also, I was busy telling you guys a lot about the new changes that are being done. So I just want to check them quickly for you guys. Mm, the new caps laws that have been um, given to us. Yes, here they are. So if you haven't been, with us, or you don't know what's been happening with regards to your education, there's been amendments that that the Department of Education has done. They've removed some topics, and they've replaced others with others. But what's important is for us to stick to what's important for it's for us to stick to what is being given out, because at the end of the day you're going to be writing an exam, and it's always best for you to write an exam on something that you actually know. So that was the biggest thing that we needed to get in line with, the fact that the caps has been adjusted. So what we know about this is that there has been amendments for the grade 11. Some have been removed, so which means you won't have to deal with some of these things. Like they removed geometrical optics, they removed 2D from your wave, sound, and light. And when it comes to electricity and magnetism, they've removed all the calculations. So guess what? In this topic that we're going to be doing, we won't be having calculations. So we'll be sticking to the theory, the understanding, the laws, and everything that needs to be done. Okay. So another thing about the grade 11 is that on the material, matter and material, the ideal gases, everything is going to be retained, the kinetic molecule theory and the Boyle's law. Okay. So for chemical changes, remember we did chemical change. There has been no amendments, and we've done most of it. And but we're gonna have to do it again because it's coming back for term 4. So chemical systems, they've removed exploiting lithosphere, and which means that you can do anything else, just not that has been done. Okay. So yes. So if you can check here, you see that they've moved some of the stuff, but in term 3 specifically, electromagnetism was amended. So which means there's some stuff that is going to be kept, but they mentioned that all calculation is removed. So in term 3, we were supposed to do energy in chemical change, but that also has been moved to term 4. So that's why I mentioned that we're going to have to do it again, because we did do it before, because when they did the amendments, it was already changed. So types of reaction, as you can see, this is what you need to know. So on term 4, it's going to be chemical change, and term 4, exploiting lithosphere, we're going to remove it. So there's going to be these few changes that you are going to have to make sure you are aware of. So for example, here is the amended percentage mark for your final year examination. For mechanics, this is what we're going to get. You're going to get 26%. It's going to count 26%. Wave, sound, and light has been completely removed. Do you see that? It's been completely removed. So meaning that you won't need to study it at all. And then electricity and magnetism, 26% weighs quite a lot of marks. So please, guys, make sure you pay attention to these ones, and remember there's no calculations. And then matter and material is going to count 16%. Chemical change is going to be 33%. So this is your final year weighing scales. And another thing that you guys need to remember is that chemical system is also not going to be part of your exam, so you don't need to do it as well. So what this means is that everything has been shrunk to make 150 marks. So please, guys, make sure that you study hard and you pass, because this is your chance. Take advantage of it. There's only going to be one paper. It's not going to be two papers like every other year where you have physics and chemistry. This year there's only one paper. Question one is going to be chemistry, and question two is going to be I think from question they're going to be divided between chemistry and physics. So I just want to check it for you. Yes, question 1 to 5 will be physics. Question 6 to 10 will be chemistry. So you guys need to make sure that you get your mark allocation correctly, and you study the things that you have to. Do not study what you don't have to, guys. These are tough times. All you need to do is get through grade 11, but knowing your work quite right. And I encourage you guys. My name is Nonkululego Madondo, and I am indeed your physical sciences teacher. Okay, now going back to what we were talking about. Yes, that is me there. We are doing electrostatics, and like you guys know, or for the new people that have just joined in our grade 11 physical science class, I usually work on the Oxford Successful textbook. And so if you guys do have it, or you need textbooks, or there's some textbooks that are too limiting for you and you need some more, you can quickly grab yourself an application. It's called Snaplify. Just get it on your app store. You can even get it in your phone. And that it's got free books from now until the 31st of December. Because of the COVID-19 problems, they've made them absolutely free. So make sure that you go and get yourself that app and get. It's not just for physical science, it's for all your other subjects. So if you do get a chance, just go in there. But what I've noticed there as well, they've removed the Oxford Successful textbook from the content there, so you might not be able to get it anymore. I'm supposing that's because all of you have taken the Oxford Successful textbooks, but nonetheless, all is well. So what are we doing today? Today we're going to be doing electrostatics and Coulomb's law. Does that ring a bell? Hope you have your books there, because this is quite a lot of work for that you need to know, and a lot of terms that you need to understand. So we're going to do revision of electrostatics. We're going to do Coulomb's law of charges. Oh, and this one we're going to do it using the Siavula textbook, because it explains them so well. Okay, so this is a Coulomb's law of charges. Then we're going to have some inverse square laws and Newton's law, but we're also going to have some, obviously, an activity that we're going to do, and I will give you guys homework that will have corrections for by tomorrow. So all of that is what is going to be done today. So guys, another thing I want to remind you guys is that in this group, we chat only by voices, and you guys are not allowed to talk back. I'm joking about that. You can, but you can send me a chat. It makes it much easier so that I can see it properly, because sometimes it can be a bit difficult to control the volume of voices and stuff like that, especially with the background things that are happening that can come through the system. So it's better when you want to ask something, want me to rephrase anything, you just send me a chat and I'll go back and I'll explain it to you. The aim here is for you guys to understand and for you guys to be A students in physical sciences grade 11. Okay? So, introduction to our overview. So this chapter, electricity and magnetism, this is what we're going to be doing for these next few days. So the overview for the umbrella of what is going to be done in this chapter is we have three categories. We've got electrostatics, we've got electromagnetism, and then we've got electric circuits. So these are the three main categories that we're going to be working with. So for electrostatics, we need to understand the Coulomb's law. We're going to be doing the electric field, and we're going to be doing the electric field strength. So you see, sometimes you can even take such a diagram, and you can make little snake, what's this, spider diagrams there, and write everything as a summary for you guys to know what each one entails. Like for example, electrostatic, you write here positive charges, negative charges, etc., etc. Then Coulomb's law, just for you to understand, and you can even put it in your room, and you can use it to study. Sometimes a summary is so much easier to understand than a lot of work. So those are some of the little tips that you guys can use to understand your work better. Okay, so after that, we're going to get into electromagnetism. Okay, electromagnetism. Here, we're going to talk about the magnetic field of an electric current. We're going to talk about the environment and overhead cables. We're going to talk about Faraday's law of induction. So if you want to, you see yourself becoming an electrical engineer in the future, this is a topic that you have to pay too much attention to, because these are the things that are going to follow through with you up until you get your master's degree. So, and then the third one, we've got electric circuits. There, we're going to deal with our conventional Ohm's law, ohmic and non-ohmic conductors. We're going to have series and parallel circuits. We're going to have power, and we're going to have energy and the kilowatt hour. So, apparently, for electricity and magnetism, there's no calculations. So I don't know how that's going to be integrated in the system, but nonetheless, I'll get back to you on that one. For now, let us get straight to understanding. So our three main parts that I just mentioned right now, it's electrostatics, electromagnetism, and electric circuit. So what is electrostatics? Electrostatics is a study of electric charges or fields opposed to electric current. Okay, so the forces of electric charges on each other explain how atoms and molecules are held in place. Excuse me for my grammar, guys. It's a computer. Okay, so we need the ability to measure their effects before using them. Does this sound a bit familiar? Remember in chemistry, there's a part where we needed to calculate things before we actually did experiments. This is something similar to that. Okay, so the second one was electromagnetism. What is electromagnetism? Is a phenomenon of the interaction of electric currents or fields and magnetic field. Are we together, guys? So that is electromagnetism. So here we're dealing with electricity and magnetism all working together in one circuit, for example. So that is what it's all about. So it's an interaction of electric currents or fields and magnetic fields. Okay, so I hope that makes sense. And then we also have electric circuit. Okay, so that is a path for transmitting electric current. It has a device that gives energy to charged particles driving the current. Can be a battery or a generator. So an electric circuit is actually a full circuit where uh, electrical current can flow. You understand? Usually, it has a battery, it has an inductor, or it has a resistance, and it's got a source, and that is an electric circuit. Okay, but we're going to get more into details with each as we go along. Okay, so let's go back to revising. Let's have some revision on electrostatics. Okay, what do we know about electrostatics? We know that electrostatics has to do with the interaction of stationary charges. So basically, it's a stationary charge, there's some field in it, and then there's some electric current flowing through it. So all materials have either positive charges, which are called protons. So all materials have either positive charges, which are called protons, and negative charges, which is called electrons. Okay, are we together? And you rub the ruler, make it hot, and then you'll see as they stick, as the papers magnetize on the ruler. So that is an example of materials having positive charge and negative charge, and that opposite actually attract. Okay, so a net charge is set to be neutral if the number of protons and electrons are equal. Okay, so once you see a net charge and they talk about a net charge that is neutral, it means that your protons and your electrons are equal. It means your positive charges and your negative charges are both equal. Okay, so a positively charged object is electron deficient. Okay, and a negatively charged object is in excess of electrons. Okay, does that make sense? So basically, that's what you need to know when it comes to revising, going back to the electrostatics. What you need to know, it's all about positive neutrons and electrons, positive and negative charges, static interactions of stationary charges. So basically, that's what it's all about. Okay, so the principle of conservation of charge. This is the net charge of an isolated system remains constant eh, during any physical process. Okay, guys, please make sure you understand, you know these terms, because if this section there's no calculations, then you best believe they'll be asking all these terms and you need to know them. Okay, so the principle of conservation of charge, the net charge of an isolated system remains constant during any physical process. Okay, so which means the q net is equals to q1 plus q2 plus q3. Okay, so the next one is the principle of quantization. Sorry about that. Quantization of charge. Okay, the principle of quantization of charge. Every charge in the universe is an integer multiple of the electron charge, which Q is equals to NQE, and QE is a standard SI unit. Okay, so it's going to be 1.6 times 10 to the power minus 19 C, positive for protons and negative for electrons. So like charges repel and unlike charges attract. Okay, and this is how this is explained. Okay, so um, we're going to talk now about the Coulomb's law, the forces between charges. What is this Coulomb's law? Okay, here what we need to know basically when it comes to Coulomb's law is that like charges repel each other while unlike charges attract each other. Okay, if the charges are at rest, then the forces between them is known as the electrostatic force. Okay, if the charges are at rest, then the forces between them are known as electrostatic forces. So the electrostatic force between charges increases when the magnitude of the charges increases or the distance between the charges decreases. So, so basically, the closer they get to each other, the more electrostatic force is between them, and the magnitude as well. If the magnitude increases, the electrostatic force will also be very high. So you see what happens. These ones are like charges, they repel each other. And then these ones are also like, these ones are unlike charges, they attract each other. So these ones will attract each other because they are not the same charges. Okay, so you see, opposite attracts like um, distract. Okay, you see that. I hope you guys understand this diagram. So what is this Coulomb's law that we've been mentioning, that there's a Coulomb's law? We mentioned that they have to do with Coulomb's law. Coulomb's law, the force that two charges at rest exert on each other is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay? So you guys are going to see the formula just now. I'm going to show you and what basically it means, because the the formula is it's a very same explanation as this theory. So make sure that you understand the formula for the Coulomb's law in order for you to be able to define it properly. The force that two charges at rest exert on each other is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay, so I just want us to go, like I mentioned to you guys, that I like the way they've structured it there on the Siavula textbook. So I want us to go and look more into the Coulomb's law. Okay. Okay, let me not jump the guns. Okay, so here we have it. So we did mention like charges repel each other, while unlike charges attract. So the history behind this, it says the electrostatic force was first studied in detail by Charles Augustin de Coulomb around 1784. Hence the surname Coulomb went into the book of histories. Through his observation, he was able to show that the magnitude of electrostatic forces between 2 points, like charges, is inversely proportional to the square of the distance between the charges. Do you see this? This is the proportional sign. This is the forces. Okay, so it says here the magnitude of electrostatics between 2 points, which is Q1 and Q2, is inversely proportional to the square distance between the charges. So this is it. So you'll have a Q1, you'll have a Q2, and you'll have a distance between these two charges, and that you must square, and that will give you the force that you need. Okay? Do you guys understand it now? Do you understand the Coulomb's law, and do you understand how it is explained according to this formula? So you see, where Q1 and Q1 are the magnitude of the two charges and R is a distance between them. The magnitude of the electrostatic force between 2 points is given by Coulomb's law. Okay, so we already mentioned the definition. So it continues, obviously, because you see now they've added a K here. So Coulomb's law states that the magnitude of electrostatic force between 2 points, 2-point charges, is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So now we've got a proportionality constant that they've also added into this formula, and that will be the K. So the K is called the electrostatic constant, and the value of K is 9 times 10 to the power of 9 and newtons per meter coulomb. Okay, and this you can just write it like this. So this is the formula for the electrostatic constant, which is also the proportionality constant of the Coulomb's law. Okay, are we together, guys? I hope that we are. And so let's continue. So similarly to Coulomb's law, to Newton's universal law of gravitation, they say here, notice how similar in form Coulomb's law is to the Newton's universal law of gravitation between 2 point-like particles. Okay, so the difference here, okay, there we had the Coulomb's law and now we have the Newton's law, which is actually the same, similarly the same, but different wording. So here for the Newton's law, m1 and m2 are the masses of 2 points, but for Coulomb's law, remember, it was the charges on 2 points. So with the um, Newton's universal law, it's the masses of 2 point like particles, and the d is a distance between them. That side is also it's not d, it's an r, and the g here is a gravitational constant. And remember here, what did we have? We have a proportionality constant. So they can basically ask you a lot when it comes to this. So you just need to make sure you know the difference between the Coulomb's law and the Newton's universal law of gravitation. The formulas are similar, but they are not the same. Okay, so make sure that you understand. Okay, so both are inverse square laws, which is what we also were about to talk about. Okay, the universal the inverse square laws. Okay, both laws represent the force exerted by particles. So it's either a point masses or point charges on each other that interact by means of a field. Okay, it could be a magnetic field, the electric field. Basically, this is what they do. Okay, so they are both inverse square laws. So we are not going to dwell much on the calculations because we've been told that there is no calculations in these problems. But I just want us to look at one just to understand how these things work. Okay, we are required to determine force between 2 points, charges, given charges, and the distance between them. Determine how to approach the problem. Okay, we can use Coulomb's law to calculate the magnitude of the force. So if you're given, for example, Q1, Q2, and R, we already know the K, so which means that you can easily find your answer. And this is how it will be. So you see, these ones are unlike charges that attract each other. So that's why it has been drawn this way. So it's also important that you understand what these signs mean. So when it's a positive and a negative, you need to know that these are opposite charges and they attract each other. If, for example, they might give you a negative, and they ask you to draw the how the charges would be like, you need to be able to do that. That they all repel each other because they are like charges. So these are certain things that you guys need to understand so that you can be able to explain this work to yourself and understand it more. Okay. So basically, there it is. It's called a free body diagram. So these diagrams here are the free body diagrams. They might ask you to draw them. You need to understand how they are drawn and why they're facing each other or facing apart. Okay. So that is that with the free body diagrams. So let's quickly go back to our slide. So I hope that you guys now understand the Coulomb's law. So just looking at it now, it makes much more sense to you guys. So okay, now we've already spoken about the inverse square law. So the inverse square law, we already spoke about it on the Siavula textbook. So the magnitude of a physical quantity that obeys the inverse square law is inversely proportional to the square of the distance from the source. Okay, let's go to our Oxford Successful textbook and see what they say about it. Okay, no, we do not have it here. But basically, what it means, guys, is what it means. It's what I've been explaining, that basically the magnitude of a physical, is one that is inversely proportional to the square of the distance from the source. So that R square at the bottom. Do you see they both had the distance in common? I'm just trying to get into the next page. I'm sorry about that, because I want us to quickly go to the problem and see what kind of problems will we see ourselves into. Um, oh yes, before we lose much time, I want us just to be able to go through some of these problems. So, okay, let's start with number one, activity one. You guys are going to have this as homework, which means you're going to do the rest where we stage off. And we're going to do them tomorrow before class. So, they say, write the meaning of the following words or terms, okay? Electrostatics, neutral, positively charged, negatively charged, column, microcolumn, nanocolumn, conservation of charge, and quantization of charge. Okay, so let's see. I think I do have our this worksheet right here. Hmm, okay, okay, guys. It seems that our our um our technology is a bit becoming a bit of a failure for us right now. So, okay, these are the meaning of the following terms. Okay, I'm not going to give you guys too much homework because we were supposed to do some of the examples together. But can someone just type for me from what we've learned? What is electrostatics to you? You can just send it to my chat, and just to test one thing that we know that where we're going, there is some understanding that's come along. So you guys can send me a chat and tell me um what what is a term electrostatics to you, okay? And then we're gonna do the other definitions tomorrow. So that one, I'd like you guys to send it for me before our class ends. Okay. So number two, stating the Coulomb's law. That one should be easy because we've already done it. Then number three, show two polystyrene spheres A and B. They hang on a thread of cotton, an insulator. Each sphere is covered with graphite, which is a conductor of electricity. Okay, so I think this is our R or D. This is our R, right? This is our R square. Okay, so now what they want to know is is the electric static force on the sphere attractive or repulsive? Mm, come on, guys. I hope you guys are typing. I just want to know one term. What is electrostatics? Just type that for me. And I'm waiting for that answer. Because now I can't tell you guys this answer without us having to deal with that first problem, which is what is electrostatics? Please send it to me. So, okay. So, is the electrostatic force on the sphere attraction or repulsion? You guys should remember what we spoke about, that same charges uh, attract and same like charges repel and unlike charges attract. So that should say something to you when you see them going against each other like that. Okay. So the magnitude of the charge on A is twice that of the charge on B. If the magnitude of A is 4, what is the magnitude direction of B? Okay, let's do it, guys. It's all about understanding. So I would like you guys to try that one too. Okay, so name the law of physics that supports your answer to question 3.2. Remember these laws? Go back to our problem that we spoke about. But because I haven't received any answer on what is electrostatics, I will not be able to display the answers today. We're gonna work them out tomorrow. So please, guys, make sure that you go through each and every problem. We're doing this activity, and tomorrow we'll be doing your corrections. Don't forget, guys, your homework is important because that's how you learn, and that's how you test how much you know and how much you don't. Okay? So okay. So the 3.4, it says if the distance between the spheres is halved, if if the distance between the spheres is halved, state and explain what the magnitude of the electrostatic force will be. So here, as much as there's numbers that are required in all of that, what's more important is how you define, because here you see it's all about explaining every problem here. They want you to explain sort of where you get it from, what does it mean, or what law is applicable to what is happening here on your figures. So please, guys, make sure that you do get in line with these problems. Okay, so the last one says if the charges are at their original position and the magnitude of one of the charges is halved, what will be the new magnitude of the electrostatic force? Okay, so please, guys, do this homework for me, I beg you. And tomorrow we're gonna do it. Okay, I haven't had anybody who's telling me what is electrostatics. Guys, come on. Surely one of you uh, knows what is electrostatics, but nonetheless, it's fine. We're almost running out of time. I hope that you are there. You are doing all your other work in order for you to complete your homework for tomorrow. Okay. So, guys, I think this brings us to the end of our lesson. Okay. This was a physical sciences grade 11 class. We were doing electrostatics. And where do we get that from? We're doing it from electricity and magnetism, which is the term 3 work that was revised by CAPS for us to do. So I hope that everybody was able to understand what we spoke about, what we did, and referring to our books that give us more enlightenment on some of these topics that we touched based on today. Please, guys, go home, do your homework on activity one. Come, let's do it tomorrow. It's fun, guys. I mean, teaching yourself. These are things that you guys are going to have to know when you go to university, because there's nobody that's going to be forcing you to study. It's all up to you. Whether you eat, whether you study, whether you play, it's all up to you. So it's very important that as much as you do your homework, you do your activities. I'm your physical sciences teacher. Thank you so much. And please be sure to catch me on my email, which is t33teendlovu@gmail.com if you have any question. And thank you guys so much for the lesson. Tomorrow we are continuing. Um, please read through your work on what is next, and we can come back here again and discuss it. Thank you guys so much, and goodbye.